राधे राधे मेरे भाइयों. Today I'm going to solve a new question of LeetCode 19. Remove nth node from the end of the list. Right. So given the head of a linked list, remove the nth node from the end of the linked list and return its sets. Means you have to remove the nth node from the end. Means if it is 2, like as in the given test case, n is 2 and the linked list is 1 2 3 4 5. So you have to remove the nth node, means second last node, from the end. So first is this and the second is fourth one. So you need to remove this and the resultant will be like 1 2 3 and 5. Means I have deleted the fourth node from the end of the list. So let me take another test case to explain you in better way. So like, see, have a look. This is the linked list 1 2 3 4 5, right? So you have to remove the third last from the node. Means this is the first, this is the second, this is the third. Means you have to remove the third last. So how the linked list will look like: 1 2 3 will be removed, 4 will be linked, and 5 will be linked. So this is the answer of the given linked list, right? So you have to remove the nth node from the end. Means nth node from the end means, like, it is, if it is a single linked list, you cannot reverse from the end, right? You need to reverse the linked list, but we don't want to do this, right? So you have to do some method so that we can go forward till that node, which is nth node from the end. So like, if see, this is a something, this is a linked list 1 2 3 4. If it nth node from the second, so how, means which position will be at from the first? So if it is at second node from the end, so at what position from it will be the from the start? So as it has 0 index from a start, 0 1 2 3. So the length is what? Linked list length is 4. So 4 minus 2 is what? 2. So just go to the second node from the first, from the start, 0 1 2. This is the. So let me take another test case. See, so a linked list is 1 2 3 4 5 6, right? So nth node means n is equals to 2, right? So means from end, this is the node we have to delete, right? From starting only, at what position he will be? So length of linked list is 1 2 3 4 5 6. 6 minus 2, that is 4. So means from starting, it is the fourth node. So 0 1. So as it is a 0 index, 0 1 2 3 4. So we have to remove the fourth node from the start. So I hope you understand the question what we have to do. So let's see how we can think of. So 1 2 3 4 5. How we delete linked list of a, how we remove node from a linked list? So if I have to delete 3, what we can do? Just link the previous node to its next node, like this. If we able to do this, the 3 will be removed. So the new linked list will be 1 2 4 and 5 if we remove this. So first condition, if it is the middle of the linked list, we have to, the deletion node is at the middle or anywhere in between. So second condition can be 1 2 3 4. If we have to delete the first node from that, means we have to delete this. So what we have to do? We have to do, just link this to the null, means previous to the null, if there is no next of this node. So the linked list will be 1 2 3 and null. Third case, what it can be? If we have to delete the first node, 1 2 3 4, we have to delete the fourth node from the end, means the first node from the starting. So you have to delete to 1. So what we can do? We can simply move head to the next position. Head is here, so simply move head to this position and delete this one. So the new linked list will be 2 3 and 4. So I tell you all the possible scenarios where you have to delete the linked list. So first, what I told you, find position from first, because we cannot traverse from the end of a linked list because it is a single linked list. So find position from the first 0 index. For this we have to find length of a linked list. And third, if you are able to find the length of the linked list, the position from first will be what? Length minus n from the last node, right? So how we can do this? So as is the given test case, 1 2 3 4 5 6. We have to delete the nth node, means third node from the last. N is equals to 3. So length is what? Length of this linked list is 1 2 3 4 5 6. 6 minus 3 is what? 3. So we have to delete the third node from the start, as it is a zero index node, we have to assume. So third node is what? From last node we have to delete this. So from starting we have to go to the third node. So 0 1 2 3 means we have to delete the fourth node, right? So how we can do? So as I already told you, if you have to delete this node, you have to keep the access of its previous node, because if you do not have previous, how will you link from this to this? You need to keep a previous node. So what you will do, you will, what you can think of approach. So I hope you understand the question. Now I will tell you the approach. How can you think of? First, traverse to the node which you have to delete. You have to delete, right? And take a previous pointer. Take a previous pointer which will be just previous, which will be just previous to the current. Then you can link the previous to the current next, right? So as what the linked list was, 1 2 3 4 5 6. So if we somehow able to take current here and previous here, so how we can delete? We can simply do previous next will be what? Current next. So it will be linked like this, and then we can simply delete what? Current. Delete current. So the linked list will be 1 2 3 5 and 6. It will be deleted, and the link 3 is went to the 5. So it is the new linked list. So I hope you understand what you have to do. First we will find the length, and there are two like edge cases. If you have to delete this node, so we can simply move to head to the next pointer. It will be automatically deleted and you can return the new head, right? And if another case, like if you have to delete this, and this can be the last node. So I will take another linked list to explain you. See, so if you have to delete this 1 2 3, if you have to delete this node, so what you can do, like if you have previous, you have current, but you cannot assign like what I was doing previous next is equals to current next. So you can simply do current next is what? Null. So previous next will be null. Previous next. So the linked list will look like 1 2 and null. Done. So I hope you understand the question. Now let me write the code so that you can explain in better way. First, length. We have to find the length. So while so take a list node temp which is on head at starting only. So I will find the length. How to and take a variable length. First it was 0. So I will run a loop, run that temporary till it is not reaches to null. And what I will do, I will keep incrementing length, and temp is equals to temp next, right? So what after next we have to find the position from the first. So position from first will be what? Length minus n, total minus last position. So it will give you the first position. Then what you have to do, we have to go till the node we have to delete as 0 index. So while length minus means till we do not reaches to the node which we have to delete. So what I will delete, so I will take a node current will be on head and previous, so that we can link. Previous will be what? Starting in null. So first what I will do, I will first assign previous to the null. I will do a dry run. First I will assign previous to the current, and then current should be the current next. So at the end, when the length becomes 0, the current will reaches to the node which we have to delete and previous. So after that what we have to do, we have to simply assign previous next is equals to current next, and current delete current. So it can be situation like if the length is, so this is the like in every test case it will run. So for some edge cases, like the linked list is 1 2 3. So if they say to delete you the node, third node from then, third node means starting means this one. So what we can do, we can simply like first traverse. So If it is the length is 0, so what we can do, if length is 0, it means if position is 0, means you have to delete the first node. So what we can write, we can simply move head to the next. Head is equals to head next. So head, as the head is the main pointer, so head will come to here and simply return head. So it will automatically be deleted. Return head. Done. So let me do a dry run. So 1 2 3 4 5 6, right? So we have to delete node, this node, means n is equals to 3. So starting, what will be the position? So length is 1 2 3 4 5 6. 6 minus 3 is what? 3. So go till 3. So I will run a loop till while position minus minus, means it will run a loop till it got exhausted, means till the current reaches to. So first current is here only and previous is here. So length is 3 is greater than 0. Yeah, 3 is greater than 0. So current, previous will be here and current will be here. Again 2 is greater than 0. Yeah, so current will be here and previous will be here. Now current will be here and previous will be here. Now position is 0. So while 0 it is false. So current is here and previous is here. So what I will do, I will simply assign previous next is equals to current next and delete current. That's it. So your linked list will be made. Now simply return head. So I hope you understand the solution as well. So let me summarize. First, find a length so that you can find the position from the start. Find length of linked list. Second, find position from start. Find position from start. That will be length minus n, means length total minus nth position. Now reach to the node, we have to delete. Reach to node, you have to delete. Right? And just simply arrange the pointers. So arrange the pointer means previous next will be current next and delete current, and afterwards simply return head. So what will be the time complexity? As I am traversing one time for to find the length of linked list, so it will take O of n time complexity to traverse whole linked list. And second, space complexity is taking, I am not making any new linked list, so space complexity will be O of n. So I hope you understand the solution as well. So I will be attaching the code link in the description. So I will be meeting you in the next video. Till then, take care. Bye bye. Jai Shri Ram.